In this video, I'll explain how I designed laser cut enclosure for my Raspberry Pi Pico electronics point controller project. This is designed for laser cutting from 3mm plywood. It's not obvious from this photo, but the enclosure has a sloping front which added to the challenge. It's been designed with interlocking tabs to make it easy to assemble. The enclosure is designed in FreeCAD, but with further modifications in Inkscape before loading into Lightburn. There's a laser cutting interlocking workbench which allows for creating boxes with interlocking edges. It has a box option, but that only works with boxes with horizontal tops, whereas I wanted a slope in front. So I designed the box myself using the Park workbench, then used the laser cutter workbench to create the interlocking parts. I then used Inkscape to edit some of these parts, including adding the switch positions and adding text and images. I then loaded these into Lightburn. Unfortunately, Lightburn is not free or open source software. You have to pay for a commercial license. Unfortunately, I'm not aware of any free open source software that can compete with what Lightburn can do, so I have to use that commercial software for this. But if you do know of some other software that would work just as well, please let me know in the comments. Just started FreeCAD up, and I'm going to create a new file. Now, one thing you will need to set up, you can do it now or later, but I'll just show it now, is the laser cut interlocking workbench. I won't be using this straight away, I'll be using it later. If you don't already have that, you probably haven't if you have not used it before, just go onto the add-on manager and just search for LC, the laser cut, and it's called LC Interlocking. And just click on and install that. I've already got it installed on here. So just show you this workbench first of all. I'm not going to be using it just yet though, but it does have a feature to create a box, and it will automatically create that box for you, but it only allows it to be a cuboid basically, so a flat box with identical left and right faces, identical front and back faces, and a flat roof. What I want to do is have this with a sloping top, and I can't do this using this. I'll still come back to this workbench later to do the interlocking part. If you are happy with just a standard box, then it will save you quite a bit of time. You literally just go in here, stick in your dimensions that you want, depending upon whether you want them inside or outside dimensions, thickness of your wood, and then it'll create the box, and then you can catch up with me later. But because I'm wanting this to be, as I say, with the sloping top, that won't work. So let's just delete that. Delete all this. Now, one of the things about the interlocking workbench is it does create all these new objects, and it can make it difficult to go back and continue. So I'm going to be saving regularly and creating new versions of the file in case I ever want to go back and make any changes. Not something you normally need to do in FreeCAD because of the parametric way it works. You can normally just go back and change some values and it'll be reflected through. Not necessarily the case here. So I will quickly just save this. As you can see, I've been playing around with some different versions, so version 0.5 here. So I've got my blank file here. Normally when I go and start part design, I'll go into the part design workbench. In this case, I need to create multiple objects, multiple bodies, and you can't do that in part design, so I'll be going into the part workbench instead. And this is going to allow, it's going to provide some of the features that we need, such as extrude. But before we do, I'm going to have to go into the sketcher because it doesn't link from the part workbench to sketcher. So I'll start with a sketch, move between sketcher and the part workbench, and then we'll come back and wrap it up with the laser cut workbench later. Start with a sketch, and it'll be on the XY plane, as you can see the top plane here. So I'm going to start by creating the base, and we're looking down from the top, as you can see, and it's basically a rectangle. I'm going to position it around the center using the symmetry constraint, and then I'm going to set the dimensions. Now for this I'm going to have the base as being the internal dimension, and the sides will be on the outside. This is going to make it just easier to create in this method, so this is the way I'm doing it. So the dimensions I'm putting in here are the internal dimensions at this point. So that's 180 millimeter length and 120 in height. Basically trying to get the maximum out of the wood that I'm using. I've got a lot of A5 wood which fits nicely on my laser cutter, so that's been used for the basis of this. Also roughly just comfortably fits in my PCB, and then when I come on to create the height, that's going to take into consideration the height of my capacitors, which are quite deep, and just give a slope in front on it. For the constraint, it's gone green. Close that and just extrude that. So switch to the part design and then use the extrude. And we're going to do 3 millimeters, which is the width or the thickness of my wood. Defaults to the Z axis, and that's what we want. So there we go. So there's the base of that. So this is the base that I've created here. And the easiest way is going to be to create the back and the front first, and then I can make the sides fit that. So that's what I'm going to do. So let's have a look around the rear. Just going to create a rectangle around the rear on the sketcher. So I'm going to bring in the external geometry of this. So this allows me to put the rectangle. You can just about click these here, but one of the things you can do is just view section so that we're cut through, because before we were on the very edge and these points were in the middle. Do a rectangle, deliberately not done that just so I can select them. So deliberately not put those together, just makes it easy to select them like that, and then just do that. And then it's just the height. So for the rear, I'm going to do 60 millimeters, but I think I'm going to do that based on the inside dimension. So I'm going to add the 3 millimeters for the bottom on here. So I'm going to make this 63 millimeters. Okay, so that's that, and now I can pad this or extrude this out. So just move back to the part workbench, choose extrude, and it's 3 millimeters. And then we need to transform this so that it's at the back. Just move it out. Now we've got 1 millimeter increment, which is probably about right. Makes it nice and easy to position. There we go. So there's our first two parts. As we make these parts, I'm going to rename them just to make it easier to know what they are. So this is the base or the bottom, and this is the rear. So now I want to do the front. So there's the rear, there's the base, and switch back to the sketcher. And so what we've got Z and X, so it should be the XZ plane. I'm going to do new section, and we're going to bring in the bottom of that. I'm going to make these coincident again, and the height this time, again we're going to go for the internal 45, so that's 48 with the 3mm for the base. Close in the parts. I'm going to extrude that by 3mm, and then I'm going to transform that. Let's rename it first. And transform that. Just zoom in a bit so you can see. There we go. Now with the front and back, we can now do the side pieces. So as you can see, this is going to be on the YZ axis. So we'll go back to the sketcher. XZ plane. Sorry, the YZ plane is the one we're wanting. We'll bring in the external geometry, which will be these points here. That might need that point there, that one there. So what we need to do is to do this so that the wood can lay on flat. So I need to go from there, go there, there, and just to join these together, we're going to use the tangent constraint, and that pulls those in a straight line together. Now we can move those to be coincident. There you go. So one of the things is, because we're going at an angle, we need this wood to be perfectly over these. So it's going to start on the front one and then rest on that back one, and there'll be a tiny little gap towards the back. Now we extrude that. About 3mm. And then we transform that to, in this case, the left-hand side. Okay. Now, let me just rename that first. Check that's right. Yeah, so that's the left hand side. We could just take the sketch and create another extrusion from that, or we could try cloning it or things like that. I just find it's better not to, because when we explode it, it might end up upside down. So let's just do it manually instead. So we're going to look from the right hand side. Again, remember it's the YZ plane. On the YZ plane. View section. Bring in the external geometry. Could, in theory, bring in that one. I'm just going to go with this. I'm going to go through the exact same steps we did the last one. Just select the whole line. I only want those points. And let's just go through that again. Close that and then extrude that. And move it into position. So now we're ready to put the lid on top. I'll just rename that actually. So now ready to put the top on. I'm going to just select one of these faces so that we can use that as the basis for the sketch. Put the sketch, click on the plane face, and we're going to bring in the external geometry of, now we need this line here. You have to be careful you don't click on the wrong bits. That one there, that there, and this one here. Again, we only want these 4 points. It's quite easy to accidentally click on that. Make sure you don't do that. So we just need the 4 end points. In fact, we didn't need to do that because we're only going to need 2. But never mind. So we're just going to use the rectangular box, and then we'll do that to there. Close that. Try and put it on here so that we can see it as we extrude. Part, extrude, and 3mm. Now you will notice that the custom direction has been set, or along normal will show you what the direction is, and that's hopefully what we want. So let's try. Yep, and that's perfect. That's the direction we want it to be. So a nice rectangular piece on there. So that's that part done. I'm going to save now and add another version just in case, because the next bit is where we start to use the laser cutter workbench. So now bring in the laser cutter. So this is going to just use this tool here, which is going to provide the interlocking tabs, the tabs that are going to go along here. So let's start by adding the parts, and we're going to add all the parts basically. Oops. So we need rear, and then we need the base. So it's all 6 parts added. Now I'm going to just choose one to do. We're going to use this bottom one and we'll create the interlocking parts all the way around. So let's start by just hiding everything else other than the base. So you can just use the space key in here. And start by choosing the front edge. And we're going to add the face. Put the number of tabs. We're going to use 3 tabs. Set them as 10mm. I'm going to turn off this dog bone hole. I'm not 100% sure about that. I believe it's something to do if you're going to be using a milling machine to create your joints rather than a laser cutter. Don't need it for a laser cutter, so I'll just turn it off. And then we can move around to the rear. I think you need to have the object. You have to have the exclude to add the face, that's right. And I'm going to put 3 tabs on, 10mm, turn off dog bone. And then we can do the same on the sides. This time I'm just going to put 2 tabs on. And now the left side. 2 tabs. And click OK, and it's created this multi-join, which has done this. So need to go back into that. And then carry on and do the same for the rest of the sides. So now we'll do the start the front, shall we? So let's hide everything else except the front. There's no bottom because the bottom is already on the base. And the front goes all the way across. So we're going to just need the top. No, we're going to need the 2 sides and the top. So the top, we'll do this first. Add face, 3 tabs. And then the 2 sides, so they come out into the front and rear. Okay, so we'll do 2 for these. Okay, so as you can see, let's put those tabs on the sides and the top. Do the same for the bottom. I have to do the 3 sides again, this side, and this side. Let's go back into the multi-joint. Hide everything except the rear. Add the top first, that's the one with 3 sides, with 3 tabs. And these are 2 tabs. Okay, and now finally we need to do these sides. As you can see, they just need the top doing. Let's Let's just do left first. The top face, and we're just going to do 2 tabs for these. And then we can bring in the right side this time. Two tabs. There we go. So that's what we're expecting. Now let's save it at this point. Now we've got the basic shape of the box. I'm going to want to put some holes into this box for various components such as power in, switches and PCB mounting holes and various other things. I've got a choice here whether I do it now at this stage or whether I do it at the next stage. The advantage of doing it here is that you get to visualize it in the 3D view, whereas the next stage is going to be in 2D. The advantage of doing it later is because it makes it slightly easier to create multiple copies with changes, because I am going to want to make 2 different versions of this. I'm going to show both, so I'm just going to use this example to show creating a couple of holes, and then I'm going to do the rest using another technique in a short while. I wanted to see the rear, and I'm going to put in a hole for a switch and for the power coming in. And these will be on the rear at the left hand side. So they're going to be on here. And I'm going to be able to do this using a sketch on this face. So create a new sketch on the plain face, and then drawing them on here. So I'll start with power coming in to the bottom, which is just going to be a circular hole with a diameter of 10.5 millimeter. And the position isn't that important, but I need to just pin it down. Well, don't need to, but it'd be most useful to pin it down so I get the sketch fully constrained. So I'm just going to provide it with a distance from here, 65, and a height from the reference as well, 15. So it's not fully constrained, but that shouldn't be a problem. We'll just go with that. And then we want to pocket these. And the way to do that in the part design is to create an extrusion with 10 millimeters. I'm just going to transform it in a little bit. Oops, that one. Then I can do a boolean between that and this extrude here. So this extrude plus the rear with the tabs and do a subtractive, no, that again, I need to select the rear tab and then the extrude. There we go, so we've got those holes in there. So now we can split these apart. I'm going to show you next a different way of doing this. We didn't necessarily have to do this here, but the advantage of this is that you can see where the components are in relation to other components and things like that, which we're not going to see so well when we do the next stage. So the next stage is where we're going to go to the laser cut interlocking workbench, and we're going to select all these and we're going to export. And what we've done is we've created this new model. So make sure that one's saved first. This is giving it a new name, so I'm going to save this as .2, then expand. And I'm going to save another version as well, just in case I ever want to go back to this one, so 5-3. So what it's done is showed you the cuts that we need, and these are the different parts. And the thing is, those, one's showing the front, one's showing the back. It's not going to be a problem, we'll just mirror that. But what we don't need is these shapes, these 3D objects now. We're just wanting to get out the cuts for the laser cutter, which are these parts here, which are these shaped 2D views. Now, if you're going to send these straight to the laser cutter, or you're going to move these into Inkscape and do them there, then you can just do an export on these. You can just select them either one at a time or multiple, export them as a flattened SVG, which is the best way to use these. But if you want to carry on editing them in FreeCAD, then what we can do is we can convert these into editable sketches. So what we can do is take, for instance, let's take the first one, so that is the front. But we've ended up with 7, we didn't need this one, number 4, because we used this one, which is one with a cut, so that was my mistake for selecting that earlier. I didn't need to select that one, but never mind. So let's just get rid of that one. Just hide that one, so just space that. And what we can do is then take one of these, so this is the front, so we'll name that shade. What we need to do is we need to switch to the draft workbench. And now, in the drafting modification menu, we've got draft sketch. So this sketch I'm going to rename is the sketch for the front. This one is, say, the left hand side, right hand side. Because I'm not going to be cutting any holes or anything in this, then I'm not worried about these being flipped. I can just use the mirror option if I wanted to. Hold down shift and it keeps it as a vertical line, so we're going to mirror it about that. There we go. So we can hide the original, and now we can convert that one to a sketch, and let's say this is going to be the right hand side, so this is on the outside. So I'm going to modification, draft to sketch, and rename that to sketch. Right. So we've got front, right, left, top, base, and then the rear. And we can edit these further. So now what I'm going to do is I'm going to look at the rear, and we're going to look at how I can add further holes to this. Now, looking at this, immediately see that this is actually upside down. That's not a problem when you're laser cutting, but it's something you need to be aware about when you're making further edits to it. I need to make sure that I'm editing it around here. So let's turn it around the right way first. So that's how I want it laser cut. It's looking from the outside. That's the top. This is the hole on the bottom for the power. So I need some holes along here to represent the holes that are going to go on the PCB for mounting the connectors. I'm going to start by creating some reference points firstly. So here, each of these is created as individual lines. So let's just first make those coincident. And then I'm going to pin this down. And I'm just going to take its real position from the origin. Just so that this can't move. Now I'm going to use some construction geometry. So click on here to turn these blue. I'm going to put a point which will be the bottom of where my connectors are going to be. Now the PCB is actually about 8 to 10 millimeters from the board because of PCB stands it's going to be on, but the connectors themselves I'm wanting to start at 4 millimeters above there. So we put that as being 4 millimeters, and I'm going to put this as the point where the PCB starts, and I'm going to make it mounted 1 millimeter in from there. Now I'm going to create another one which will represent the top position, just because this is going to make it easier to. I'm going to do 20, so that's going to give us plenty of space to be able to put them in. So I'm going to do 20 millimeters from there. So it's going to be a spot, it's going to be in line with that, and it's going to be 20 millimeters. But I've just realised I've made a mistake here as well. It needs to be relative to this height, because that is where the start of the baseboard starts. So let's just pin that down. Get rid of that constraint there, and instead it wants to be 4 millimeters from there. And then this one wants to be 20 millimeters from there. Hide these. Or would you turn the visibility of them off? I'll just turn all these off. So now we've got these two points, and these are just showing the top and bottom of each of my connectors and relative from these to where they are on the PCB. The first one wants to be start at 2mm in. So we're going back to normal geometry because these are going to be genuine holes. Those should be horizontal. And it should be 2mm from there to there. Then I want the other end to be and I'm always going to be coming back to this point. The reason being is otherwise if I do it everything relative distance wise, there could be a potential drift. So I've created all those now. If I click close, now you'll see that make sure I'm lined up, that is representing the holes, and as I say it's upside down, so if I just turn it round, and remember these were created by editing the 3D model, these are created by editing it in 2D model after we've converted it into these 2D shapes. You can do either. You can also do it outside of FreeCAD, but I find the advantage of doing it in FreeCAD is that you've got these really good constraints which make it easy to get the dimensions exactly how you want them. Now I do need to also put some holes on the base and some holes on the top for switches, and I'm going to carry on and do those in here. So there's that, and then the final part to do is the top, which is where the switches are going to be. And then I can export each of these parts. I'm going to export them individually. You could export them as one. I'll just export them individually, and then we can bring them into Inkscape and have a look at what we can do with them from there. So this is the front. And hopefully that's us finished in FreeCAD, but we do have the option to still come back, and I've been regularly saving this just in case we have any issues. So now that I've exported these as SVG files, I can open these in any SVG editor. One of the tools I use is LibreOffice Draw, and that's probably the one I'm more familiar with, but doesn't have the same capabilities as Inkscape, which is the one I'm going to use here. You can use whichever you're more familiar with, but I think the extra features that are available in Inkscape are probably better, more appropriate here, but it does mean that I'm not as familiar with it as I am with other tools. So let's go ahead and open. I'm going to look at the back first, because that's, and I'm just going to open the point controller box here. I had a problem here using the SVG file. I don't know why, but it appears to have imported as straight lines. To overcome this, I exported from FreeCAD as an AutoCAD file instead. However, in later attempts, I exported it as an SVG file, and that worked. I haven't found the reason why it didn't work the first time, but just to be aware. If anyone has more experience with this and know why this may have happened, please let me know in the comments. But this is why you'll see that the file extension looks different, but otherwise it's the same, and I was able to edit using the SVG export in later attempts. Also, I'm going to have to rotate this because, as I said, it's upside down. It's going to be a lot easier if I rotate it here. Just use the rotate button. And on this example, I just want to add some text. I want the text to be engraved rather than cut. So the easiest way to do that is just to use a different colour. Okay. So we can change that. We should be able to change the fill, stroke colour. We want the stroke to be quite a small thickness, and we've just got the fill there. So the reason I've done this a different colour is that the black represents the cuts and the red will represent the engraving, and you'll see this later on when I open it into Lightburn. I'm just going to put some text here to label these up as well. I'm going to try cutting this now before I move on to any of the other parts, because I want to make sure that this is working correctly. So I'm going to export it, and I am going to export it back as an SVG. I won't use the export, use save as. I'm going to call it rear edited. And now I'm going to switch to Lightburn. So here we are in Lightburn, and this shows roughly your cutter area. So this has already been set up for my particular laser cutter. And I'm going to open the file, all supported files. And there we go. And what it's done automatically is it's brought it in. The black lines are set speed and power 170 speed, and then 100 power, full 100% max power for line, and this one's for fill. Let's have a look at the preview. Just launching this. So here's the preview. You can actually see that it is all filled. It is filled. So that's good. So I just need to orientate this 90 degrees because that's how I've got mine set up I'm going to find the home, and then we're going to laser cut this. So in my case it has to be offset slightly, and it has to be this way round. Let me go and do that. For the front piece, I'm going to show you how you can do it all in Lightburn. Let's start by opening up the front. So all support files. So we've got the front one there. And I'm going to finish creating it all in here before I reorientate it. Although it is actually upside down. So I'm going to just turn that the right way around first, because these inserts are for the bottom and it sticks up for the top. So let's just turn that full. Pressing the shift key makes it move for convenient size. So there's my cuts. What I'm going to do is create a new layer, which will be for just some engraving. I'm going to bring in an image, import, and then this is a logo that I'm wanting to put on it. It has detected this as an image, and I'll do another layer with the text on. I'm just going to put with my website details on. So I wanted to just reduce the size of that. I'm going to let's try something like that. So model railway point controller, and then the website. Just take it a tiny bit smaller. So there we go. So you can create any changes you want on here. I'm just going to have a look at how this is going to look. So that looks about right. So you can actually do play. First thing, let's stop that. I want these in a different order. I want the line to be last, because that's going to be cutting it out, and I don't want the risk of it cutting out and dropping out before I've got the engraving to do. Shouldn't be a problem on this, but we'll do that anyway. So we'll do the engraving first, and then do the outside cuts. That's just need to set the appropriate speeds and things. So I'm going to do 3000 for these. That should be a fill as well, actually. And 40% is what I think works best. So obviously these all depend on your own personal laser cutter, so I wouldn't be able to use these settings. And then 190 and 100. Now I've completed it, I can turn it around 90 degrees so that it fits on my bed. And then I can do a preview. One thing I tend to do is I will just create a little rectangle around it. So turn this on and turn the others off. I run it at speed 3511, 11% power, and what that's going to do is just do a very faint trace around where it's going to print so that I can make sure that it's fully on the wood. That may even allow me to put this on the same piece of wood that I've just used. So now I'm going to show how you could use Inkscape to add further features onto the drawing. I've opened up the SVG, so you see this is the original SVG file. As such, it's opened within just its own frame. It didn't appear off screen or have an A4 page like when I used AutoCAD format did. So this is good. And for this, I want to draw some holes for the switches. I thought this might be quite good to do in Inkscape. One, because the positioning isn't so important, but also because it then allows them to be moved around. So I'm going to start by creating some circles. I don't know. Fill, I want to be no fill. That's better. And it looks like it's set to black. So I want to set this to 6mm. And I want to set the width to 6mm as well. So there we go. So that's the hole that I need for the switch. And then I need a rectangular slot. And again, I can use these to set the dimensions. So it must be 2mm wide by 1mm high. Now the challenge is I need a set distance. I need 6mm from the centre of there. Now that would be very easy if I was in FreeCAD. What I can do is what I can do is align them together. Centre, centre. And so I need to now move 5.5mm down. So I could just use the Y value, which is 37.5, say, and add, say, 5.5. So move that down to it's 43. And now what I can do is group those, and now I can use those as a single group, and this is going to be an advantage here because then it means I can create multiple copies of these for each of the point switches that I'm going to put on here. Then for each of these I need two smaller circles for the LEDs. So these should be 5mm. So again, just draw a circle. Set it to width to 5 and height 5. Now I need to draw some lines on this. This is representing the track and how it's going to go. And actually one of the nice tools here is this pen tool, which can draw curves, straight lines. What we're going to do is literally go from the switch. Now I'm going to draw them as straight lines, but then we're going to add the curves onto them afterwards. So start out straight, it's going to be a curve down to here and then straight to that. And what we can do is use that tool to create the curves, which is kind of a nice feature. Now, tempted to just change the thickness of this line, and that gives a nice thick line in theory, but actually it doesn't work like that. Let me just move this text out of the way. In the wrong move. What I think we'll do, we'll move this status LED over a little bit. So what would happen if you made this a thick line is that when you get into the engraving, then it just ignores that and it will just do a single thin line. So what we need to do is to actually duplicate that. In fact, it's pretty easy just to draw it again, to be honest. So go back into that pen tool, draw a little line here. Now you can be more accurate than me with this, but just to give you an idea of sort of what we're hoping to achieve. And then we can curve that again. And we can manipulate these points so that what we do is put another point in there. So I've made the top lines a bit further apart. That's roughly what I'm trying to achieve on here, and then we can just fill that. So this needs to be filled in red and the stroke in red, and then this will create that as engraved. You can spend more time just trying to clean up some of these bits. So I could save it with the same file name, or I'm just going to put the word edited. So I've got the original, I can go back to if I want. So now, okay, in Lightburn, so as you can see, I've just been doing the side panels. Didn't need to do anything with those, just loaded them straight in as the original SVG files, imported them in together. So So if I just open that file, you see it's come in and it's moved them all onto the right layers. So number 27. So it looks like it's used a different colour for these, and that's fine. In fact, that's probably good, because what that means is I can move that up to move them into order. So I want to do the engraving first, and that's a fill. These should not be fill, this should be a line. So it's going to cut. So that should be, change the speed, 190 and 100. And then this is 190, 100. They're just my settings for my particular laser cutter. I created the first draft with a laser cutter, and there's a few things I've decided I need to tweak. A few changes I'd like to make on here. The size of that hole was 0.5 millimeter too small, and some of these holes were slightly too big. Well, they worked, but they were bigger than they needed to be. So I've reduced those. Also going to change this to 19 volts. That's a change that I made on the design from my original sketch. And I'm going to do all those in FreeCAD first, and then export it again. So I've made the changes I want in FreeCAD and I've re-exported it. I've exported it as an SVG this time, and this time it's worked. I don't know why. When I tried to export it before, these had triangular shapes, and it's exported now as a circle. I don't know. I did resize this, and I've resized all these. Didn't touch this, but for some reason it exported this time. Anyway, means I can use this, so that's good news. I'm going to turn the whole image round 180 degrees so that it's the right way around. So this is looking at the back, and these are the connectors. And one of the advantages of doing this in Inkscape is I've got the other window open. I can just select all this text. Oops. And copy and paste it from one to the other. I just need to position it correctly. Change that to the 19 volts. Oh, I've accidentally brought in these, but that's alright, I'll just delete those. That's going to allow me to change that to 19 volts. Everything else should stay the same. So this is the rear, updated and edited. I'll move the rest out so that it doesn't get confusing when I come to laser cutting. The other thing that I want to change is a different file this time. So here's the output. Now the main thing that I need to change in here is that the whole thing is upside down. It isn't clear from looking at it, it isn't clear from FreeCAD. And you would think these look like they're equally spaced, but because this is derived from a sloping top, these are in fact slightly more to one side than the other. So effectively the whole thing is upside down. But that's not a problem, we should just be able to select everything that's inside there. Careful not to select any tabs. Create that into a group and rotate it. And then just move it appropriately. Now, notice this didn't move, so this is actually one group by the looks of it. So let's see if we can ungroup that. There we go, select those. Just group those back together so that when we rotate it, they move together. So that's, I wanted to rotate. I'm going to use these to rotate it. Yep, that was right. Just double checking, so it starts with the holes that are close to the top, finishes with the holes that are close to the bottom. So there we go. So that should now be the correct way around, and I can cut that again. Just have a quick look. I'm quite happy with everything else. Thanks for watching. I hope you found that useful. If so, please give the video a like and leave any comments you want in the comments below.